For centuries, humanity has gazed upon the heavens, searching for answers, and often, finding comfort. We saw tranquil nebulae, cosmic canvases painted with soft, ethereal light, vast, serene nurseries where stars were gently born. Among them, the Orion Nebula. M42 has long stood as an icon of cosmic beauty. Just a faint smudge visible to the naked eye, in the sword of the mighty hunter. Through our earliest telescopes, it appeared as a breathtaking cloud of shimmering gas and dust, a peaceful, luminous haven, where fledgling suns slowly awoke. It was a picturesque cradle, an artist's dream of creation unfolding in slow motion, a testament to the universe's delicate touch. But what if everything we thought we knew was wrong? What if this idyllic portrait was merely a deceptive veil? Enter the James Webb Space Telescope. Its golden eye, piercing through the cosmic dust, has unveiled a truth far more profound, and infinitely more terrifying. The Orion Nebula is no peaceful nest. It is a crucible of chaos, a maelstrom of unimaginable forces, a battleground where creation erupts from destruction. This isn't a gentle awakening, it's a violent birth. Imagine yourself, suspended precariously at the heart of this cosmic inferno. Before you, a storm zone. Radiation, from newly ignited supermassive stars, blasts outwards in furious waves, stripping electrons from atoms, ionizing vast swathes of gas, turning what was once a cool, calm cloud into a superheated plasma. This isn't a gentle warmth, it's a searing fire, capable of vaporizing worlds. It carves out colossal cavities, reshaping the very fabric of the nebula with brutal efficiency. Then, the gravity. Not the subtle tug we feel on Earth, but the crushing, relentless embrace of gas and dust, collapsing inwards under its own immense weight. It pulls, squeezes, until the very atoms are forced together, igniting the nuclear furnaces of new stars. These nascent suns, still swaddled in their cocoons of gas, are not quiet infants. They scream into existence, unleashing powerful shockwaves that ripple through the nebula like interstellar tsunamis, tearing apart existing structures, igniting new collapses. And through it all, twisting, distorting, are the magnetic fields. Invisible lines of force, generated by the turbulent, ionized gas, and by the powerful dynamos within the forming stars themselves. They coil and knot, guiding streams of superheated material, shaping the jets of plasma that erupt from stellar poles. These aren't gentle currents, but cosmic geysers, blasting outwards at hundreds of kilometers per second, carving channels of destruction through the interstellar medium, sending material rocketing across light years. This is the Orion Nebula, a place where the most beautiful elements of creation are forged in the most dangerous conditions imaginable. It is the most prolific stellar birthplace in our entire galaxy, yet also the most violent. A stark reminder that even the most serene vistas of the cosmos can conceal an untold ferocity, a raw, untamed power, that utterly dwarfs our human comprehension. It is a place of breathtaking beauty, and terrifying, life-giving destruction. From the profound stillness of the cosmic ocean, to the violent cradles of creation. We journey now to a place of unparalleled beauty, a terrifying, life-giving destruction. A celestial forge that utterly dwarfs our human comprehension. This is the Orion Nebula, a nebula familiar to every human eye that has gazed skyward, yet a phenomenon whose true nature has unfolded across centuries of relentless inquiry. For millennia, it hung there, a faint, fuzzy patch nestled within the sword of Orion the hunter. To the naked eye, a mere smudge, an anomaly against the sharp pinpricks of countless stars. Ancient civilizations, across continents and cultures, must have noticed its subtle presence, perhaps attributing to it mythic significance, a cosmic mist, a forgotten god's breath. It served as a silent guide, a subtle landmark in the grand celestial tapestry. Imagine yourself under a sky untouched by light pollution, thousands of years ago. You look up, past the familiar constellations, and there, a shimmering haze. No telescope to resolve its secrets, only the vast, echoing silence of the night, and the ceaseless turning of the heavens. It was a mystery veiled in starlight, hinting at something beyond immediate understanding, a profound invitation to wonder. Then came the dawn of a new era, the birth of the telescope. A fragile instrument, yet one that shattered the old heavens, revealing realms previously unseen. In 1610, a French astronomer, Nicolas Claude Fabry de Peiresc, turned his rudimentary lens towards this celestial enigma. What he saw was revolutionary, no longer a mere smudge, but a cloudy star. This was the first recorded observation, a tentative step into an entirely new dimension of cosmic understanding. Peiresc had glimpsed beyond the naked eye's limit, identifying something that was neither star nor planet, something diffuse and vast, a nebulous entity that defied easy categorization. It was a revelation, hinting at the profound complexity hidden within the seemingly simple fabric of space. Decades later, in 1656, with improved optics, the brilliant Dutch scientist Christian Huygens set his gaze upon the same region. What he observed was even more astonishing, a marvelous assemblage of stars intricately woven within the glowing cloud. He meticulously sketched what is now known as the Huygens region, a luminous heart within the nebula, a cluster of bright young stars that seemed to illuminate the surrounding gas. Huygens's detailed drawings were a testament to the growing power of astronomical instruments, revealing a structure previously unimagined. Yet, even with these advances, the fundamental nature of this cosmic cloud remained elusive. Was it simply a distant galaxy unresolved? A formation of incredibly faint stars? The universe was beginning to reveal its secrets, slowly, piece by agonizing piece, challenging every preconceived notion of the cosmos. The true revolution arrived not with bigger lenses, but with a fundamentally different approach to light itself. The 18th and 19th centuries ushered in the era of spectroscopy, a technique that dissects starlight into its constituent colors, like a cosmic fingerprint. Scientists, by analyzing the unique spectral lines emanating from the Orion Nebula, made a groundbreaking discovery. This vast cloud was not merely reflecting light, it was actively glowing. Its emissions revealed the undeniable presence of ionized hydrogen, vast oceans of superheated gas, energized and emitting its own brilliant light. This was a profound shift. The nebula was not just a passive object, but a dynamic, energetic entity, a colossal cosmic engine humming with unseen forces, its light a direct testament to the raw power contained within. As the 20th century dawned, another transformative tool emerged, astrophotography. Long-exposure photography allowed telescopes to gather light over hours, even nights, revealing details utterly invisible to the human eye, no matter how skilled. The Orion Nebula, previously seen as a somewhat indistinct glow, exploded into breathtaking clarity. Filaments of gas, sweeping arcs, titanic shock waves, all became visible in exquisite detail. These images unveiled a frantic, beautiful chaos, swirling patterns of gas and dust, sculpted by powerful stellar winds and intense radiation. It was here, within these incandescent tendrils, that the final, monumental truth began to coalesce. This wasn't just a cloud, it was a stellar nursery, a cosmic womb where new stars are forged in cataclysmic splendor, a direct link between the primordial gas and the birth of suns. From a guiding smudge in the ancient night, to a violent crucible of creation captured in dazzling photographs, our understanding of the Orion Nebula has mirrored our own journey into the cosmos. It reminds us that every pinpoint of light, every indistinct haze, holds within it untold stories, waiting patiently for our curiosity, and our ingenuity, to peel back the layers of cosmic mystery. A timeless beacon, forever evolving in our perception, forever shaping our place amongst the stars. Our journey through the cosmos often begins with a distant gleam, a whisper of light that has traveled across unimaginable voids. Each one, a story waiting to unfold, a profound mystery urging us to look closer, to understand our place in its grand tapestry. And among these myriad beacons, One stands out with an almost primal intensity, a cosmic womb ceaselessly giving birth to new worlds, new futures. This is the Orion Nebula. An ethereal cloud, both beautiful and terrifying, a swirling maelstrom of gas and dust, located a staggering 1,344 light-years from Earth. To truly grasp that distance, imagine light, the fastest thing we know, taking over a millennium to reach us from this stellar nursery. If you were born today, its light would only just be arriving from the time of the Crusades. It is a cosmic time capsule, delivering ancient photons that tell tales of creation. And its sheer scale is equally breathtaking. Spanning approximately 24 light-years across, it dwarfs our entire solar system, consuming it countless times over. If our Sun were at its heart, its outer reaches would extend far beyond the orbit of Neptune, into realms we can barely fathom. Yet, even this vast expanse is merely a luminous blister, a tiny, incandescent pocket, within a much larger, darker entity, the Orion Molecular Cloud Complex, or OMC-1. This colossal complex is a sprawling reservoir of cold, dense molecular hydrogen, the raw material for stars, stretching hundreds of light-years across. M42, the brightest part we see, the nebula itself, is merely its most energetic and luminous region. It's where the cosmic forces of gravity and radiation are most fiercely at play, orchestrating a symphony of destruction and creation. At the very heart of this fiery spectacle, the engines that drive its relentless activity, lie four colossal O-type stars, bound together in what we call the Trapezium cluster. Among them, one star reigns supreme, Theta 1 Orionis C. It is a true behemoth, radiating an unimaginable torrent of ultraviolet light, a ceaseless barrage of high-energy photons, so potent that it actively carves and sculpts the surrounding gas and dust. Imagine, this star, an atomic furnace, unleashing enough energy to literally boil away gas clouds, pushing them into magnificent, shimmering columns and intricate tendrils. Its intense stellar winds, supersonic flows of charged particles, create shockwaves that ripple through the nebula, stirring the very fabric of space, preventing some regions from collapsing, while simultaneously compressing others, priming them for the ultimate act of creation. This sculpting, this relentless erosion by light, is not just a destructive force. It's a fundamental part of the star-forming process. Within the densest pockets of gas and dust that manage to resist this stellar onslaught, gravity begins its patient, inexorable work. Under its silent command, vast clouds of molecular hydrogen, once spread thinly across the void, start to contract. As these immense, diffuse envelopes of gas draw inward, they become hotter, denser, spinning faster. Over eons, these regions collapse further and further, until they form what we call protostellar cores. These are the embryonic hearts of future stars, still shrouded in their thick, dusty cocoons, but now radiating the first hints of internal heat. They are the initial whispers of a nascent sun, beginning to awaken. And as these protostars spin, they draw in more material from their surroundings, forming flat, rotating disks of gas and dust around them. These are protoplanetary disks, or proplids. They are the ultimate cosmic construction sites, the crucibles where the very building blocks of planets come together. Within these swirling eddies, dust grains collide, stick together, grow into pebbles, then rocks, then planetesimals, eventually coalescing into planets. It is here, in these fragile, luminous rings, that the seeds of future solar systems are sown. Here, amidst the chaos and brilliance of the Orion Nebula, a new generation of worlds is being forged, echoing the very process that gave birth to our own Sun, our own Earth, our own existence. Each evolving star, each nascent planet, a testament to the universe's endless capacity for renewal, a continuous cosmic dance of creation, forever unfolding before our wondering eyes. Echoing the very process that gave birth to our own Sun, our own Earth, our own existence. Each evolving star, each nascent planet, a testament to the universe's endless capacity for renewal, a continuous cosmic dance of creation, forever unfolding before our wondering eyes. Yet, this cosmic dance is far from a gentle waltz. Within these stellar nurseries, unseen forces rage, sculpting, destroying, and creating with a power that defies human comprehension. To truly understand the birth of stars, we must journey into the heart of a nebula, a celestial crucible where raw energy carves out destiny. Imagine yourself at the very threshold of this immense gas and dust cloud, a swirling canvas of creation. Your perspective shifts, allowing you to perceive the invisible currents and titanic pressures at play. Dominating this landscape are the most massive, incandescent stars, the titans of the Trapezium cluster. They are young, vibrant, and incredibly destructive. From their scorching surfaces erupt powerful stellar winds, torrents of charged particles streaming outwards at velocities reaching thousands of kilometers per second. This isn't just a breeze, it's a cosmic hurricane, a relentless outflow of matter and energy that acts as a colossal broom, sweeping away vast swathes of gas and dust. Accompanying these winds is immense radiation pressure. The sheer luminosity of these stars, their blinding light, exerts a tangible force. Each photon, massless as it may seem, carries momentum. Multiply that by quadrillions of photons, cascading outward, and you have an irresistible push. This combined assault of stellar winds and radiation pressure carves out cavernous voids within the nebula, pushing the dense gas away from the stellar giants, creating the very hollows and shimmering walls we observe. It dictates where new stars cannot easily form, and paradoxically, where they must eventually emerge. Further into the nebula, closer to the embryonic stars still shrouded in their cocoons, we encounter something far more violent. Here, shock waves rip through the interstellar medium. As young protostars begin their ignition, they often expel powerful, tightly focused jets of plasma, streams of superheated gas traveling at supersonic speeds. These jets, like cosmic spears, collide with the denser pockets of gas and dust surrounding them. The impact is catastrophic. The sudden deceleration of this supersonic plasma generates shock waves, glowing intensely as the gas is heated to incandescence. These are the spectacular Herbig-Haro objects, or HH objects, luminous knots of gas that reveal the fury of stellar youth. HH1 and HH2 are classic examples, brilliant beacons in the cosmic darkness, telling tales of material being violently ejected and sculpted. Such jets don't just create dazzling light shows, they are crucial for a star's birth, shedding excess angular momentum, allowing the star to collapse further and truly begin its life. But not all forces are overtly violent. Some are subtle, yet profoundly influential. We are talking about magnetic fields, the unseen architecture of the universe. Though invisible to our eyes, these magnetic threads permeate the nebula, guiding the flow of gas and dust. Like an intricate web, they can channel material towards nascent stars, or conversely, act as a brake, preventing collapse. Imagine colossal, invisible pipelines, directing the cosmic currents. These fields play a vital role in regulating the collapse of gas clouds, influencing the shapes of filaments and dense cores where new stars are poised to form. They are the silent orchestrators, ensuring that the chaotic dance has an underlying structure. Now, consider the very fabric of the gas itself. It is not static, but in constant, furious motion. Turbulence is everywhere. Gas within the nebula moves at supersonic speeds, creating a maelstrom of colliding streams and swirling eddies. This isn't just random motion, it's a dynamic force that acts as cosmic pistons. When these turbulent flows collide, they can compress gas to immense densities. This compression can be the critical trigger for star formation, overcoming the natural tendency of gas to spread out. It's a chaotic ballet, where the very randomness of motion paradoxically ignites the ordered process of stellar birth. Without this turbulent churn, many regions would remain quiescent, forever awaiting the spark. And finally, the most energetic assault from the very young stars themselves, X-ray fury. As these infant stars are still gathering mass, they possess powerful, tangled magnetic fields that undergo intense reconfigurations. This often leads to massive magnetic flares, and even super flares, unleashing torrents of high-energy X-rays. Unlike the visible light or stellar winds, these X-rays penetrate deep into the surrounding gas. They don't just heat it, they can cause X-ray dissociation, tearing apart molecules and ionizing atoms. This high-energy bombardment significantly alters the chemical composition and temperature of the nebula, influencing the conditions under which planets might eventually form. It's a searing gaze, a destructive embrace that shapes the environment for future worlds. These forces, stellar winds, radiation pressure, shock waves, Herbig-Haro objects, magnetic fields, turbulence, and X-ray fury, are not isolated phenomena. They intertwine in a complex, relentless ballet. Each force influences the others, creating a feedback loop of destruction and creation, a continuous reshaping of the cosmic landscape. This nebula is not just a pretty picture, it is a battleground, a crucible where the raw materials of existence are forged, where the universe's endless capacity for renewal plays out on a scale that humbles and inspires us. It is the very engine of cosmic evolution, forever unfolding before our wondering eyes. In the cosmic ballet, we often gaze upon nebulae and see only beauty, a celestial tapestry woven with starlight and gas. Yet, behind that serene facade, lies a truth far more profound, a truth whispered by the universe itself. This is not merely a pretty picture, it is a battleground, a crucible where the raw materials of existence are forged, where the universe's endless capacity for renewal plays out on a scale that humbles and inspires us. It is the very engine of cosmic evolution, forever unfolding before our wondering eyes. Deep within these stellar nurseries, we find the nascent cradles of worlds, the protoplanetary disks, or proplids, as they are known. These swirling whirlpools of cosmic dust and gas are the workshops where planets are born. Imagine a vast, flattened disk, many times the size of our own solar system, composed primarily of hydrogen and helium, the universe's most abundant elements. Interspersed within this primordial cloud are heavier elements, traces of silicates, iron, and carbon, along with frozen ices of water, methane, and ammonia. Within this chaotic yet ordered disk, a delicate dance of creation begins. Microscopic dust grains, tiny specks no larger than smoke particles, collide gently. They stick together, growing incrementally, patiently, like cosmic snowflakes accumulating mass. Over millions of years, these tiny particles coalesce, forming pebbles, then rocks, until gravity itself takes over, drawing together these growing fragments into ever larger bodies, the planetesimals. These are the building blocks, the embryonic planets that will eventually sweep clean their orbital paths, clearing the way for grander worlds. It is a meticulous, slow-motion ballet, the very choreography of creation. But the universe is rarely peaceful, especially in the heart of a vibrant nebula. In regions like the Orion Nebula's Trapezium cluster, a cosmic storm rages. Here, intense ultraviolet radiation pours forth from colossal, young stars, a searing torrent of energy unlike anything we experience in our quiet corner of the galaxy. This phenomenon, known as photoevaporation, is a brutal test for any aspiring planetary system. Think of it, a relentless wind of pure energy, stripping away the outer, cooler layers of these delicate protoplanetary disks. The lighter gases, hydrogen and helium, are heated, ionized, and accelerated away into interstellar space, leaving behind a dwindling reservoir of material. For a planet to form in such an environment, it must do so quickly, before its nursery is entirely swept away, a desperate race against time and the crushing power of stellar winds. This stark reality contrasts sharply with the more sheltered, peaceful regions of the cosmos, where disks can endure for tens of millions of years, slowly, patiently giving birth to planets. Yet, the universe's spectrum of creation is far broader than mere stars and planets. Between these two titanic categories lies a fascinating class of objects, enigmatic wanderers that blur the lines of cosmic definition, the brown dwarfs. Often dubbed failed stars, these celestial bodies are too massive to be considered planets, yet lack the necessary mass to ignite sustained nuclear fusion in their cores, the defining characteristic of a true star. To be precise, a brown dwarf typically possesses a mass between 13 and 80 times that of Jupiter, or, put another way, less than 0.08 times the mass of our own Sunday. They are caught in a perpetual twilight, glowing dimly with the residual heat of their formation, a faint, crimson ember in the vast darkness. The Orion Nebula, a hotbed of star formation, is also remarkably rich in these elusive brown dwarfs. Scientists have discovered hundreds, perhaps thousands, of them lurking within its gas and dust. What makes these objects even more intriguing is the discovery that many brown dwarfs, just like their stellar counterparts, are surrounded by their own protoplanetary disks. Imagine a miniature solar system, orbiting a sun that never quite managed to shine. These disks, though smaller, are still rich in the raw materials for formation, raising profound questions about what kinds of worlds might coalesce around these dim, cool objects. Could we find super-Jupiters, or even icy, rocky planets, orbiting a failed star? The formation of brown dwarfs themselves remains a captivating puzzle, with several competing theories. One proposes direct collapse, where a cloud of gas and dust simply collapses under its own gravity, just like a star, but fails to gather enough mass for fusion. Another theory suggests ejection, where a brown dwarf forms within a multiple star system and is later gravitationally flung out, a lonely cosmic outcast. A third intriguing hypothesis points to disk fragmentation, where a large protoplanetary disk around a forming star breaks into smaller pieces, each fragment then collapses to form a brown dwarf. Each scenario paints a picture of a universe constantly experimenting, continuously exploring every possibility within the laws of physics. From the chaotic cradles of protoplanetary disks, to the brutal tests of photoevaporation, and the enigmatic existence of brown dwarfs, the cosmos continuously unveils its boundless capacity for creation and destruction. Each discovery peels back another layer of understanding, revealing a universe far more intricate and dynamic than we could ever imagine, a testament to the endless wonder that unfolds before our wondering eyes. The cosmos continuously unveils its boundless capacity for creation and destruction. Each discovery peels back another layer of understanding, revealing a universe far more intricate and dynamic than we could ever imagine. And nowhere is this breathtaking complexity more vividly displayed than within the heart of the Orion Nebula. Beyond its dazzling nebulae, Orion is a colossal, interstellar chemical workshop. Imagine a vast laboratory, light years across, where elements recombine, forming an astonishing array of molecular species. Scientists have identified over 60 distinct types here, from ubiquitous hydrogen, H2, and carbon monoxide, CO, to ammonia, methanol, and complex polycyclic aromatic hydrocarbons, PAHs. These carbon-rich, soot-like molecules are crucial building blocks for larger organics. This molecular diversity is a profound window into the potential for life's precursors to form, even in the harsh vacuum of space. How do these molecules form amidst such extremes? Tiny, resilient dust grains, scattered throughout Orion's gaseous expanse, act as crucial interstellar catalysts. They are miniature chemical factories. When atoms and simpler molecules collide with these grains, they stick to the cold, icy surfaces. Here, protected from harsh radiation, they move, encounter other atoms, and react. These surface reactions build complex ices, layers of frozen water, carbon dioxide, ammonia, and methanol. Within these icy mantles, more intricate organic molecules are patiently synthesized. These dust grains are the nurseries where the raw ingredients for planets and perhaps even life are nurtured. Yet, Creation in Orion is inextricably linked with destruction. Dominating the nebula's core are massive, luminous young stars, titans whose ferocious ultraviolet radiation sculpts the gas and dust. This powerful UV light is a double-edged sword. While energizing molecules, it carries enough punch to break their delicate bonds. This process, photodissociation, tears molecules apart, transforming stable compounds into highly reactive fragments. It's a cosmic paradox. The very energy fueling the nebula's brilliance also shatters its chemical creations. But this destruction isn't an end, it's a dramatic beginning. Liberated fragments become perfect ingredients for forming entirely new, more complex, molecules. It's a dynamic cycle of dismantling and rebirth. Now, let us turn our gaze to the Orion bar. This incandescent ridge of gas and dust is a quintessential photodissociation region, or PDR. Here, intense ultraviolet radiation from the nearby Trapezium cluster slams directly into a dense wall of molecular gas. It marks a sharp, energetic frontier, a battleground where stellar radiation meets the resilience of cold molecular clouds. Within the Orion bar, a dramatic chemical gradient exists. Closer to the hot stars, simpler molecules are ripped apart. Further away, shielded, more complex molecules can survive and thrive. The PDR acts as a natural laboratory, showing this constant push and pull, where annihilation paradoxically creates conditions for novel chemical pathways. But Orion's chemistry isn't solely driven by light. Violent, high-speed outflows from nascent stars, like those from the chaotic BNKL object, generate powerful shockwaves. These cosmic sonic booms compress and heat the gas, triggering shock chemistry. Intense temperatures and pressures accelerate reactions, forging new molecules in a whirlwind of energy. It's in these turbulent regions that scientists detect significant amounts of deuterated molecules, where hydrogen atoms are replaced by their heavier isotope, deuterium. This presence, alongside abundant water vapor, tells a remarkable story. Life's building blocks, complex organics and water, can emerge and flourish even within the most violent, energetic environments in the cosmos. The Orion Nebula is more than just a stellar nursery. It is a profound testament to the universe's innate chemical ingenuity, a vast, dynamic laboratory where the raw ingredients of existence are continuously forged, broken down, and reassembled. From the simplest elements to intricate organic molecules that whisper of life, Orion reveals a cosmos constantly churning, creating, and evolving. It's a breathtaking reminder that wherever we look, the universe is not just spectacular, it is fundamentally, endlessly alive with possibility. We've journeyed through Orion's heart, witnessed its grandeur. But this celestial masterpiece is not static. It is a living canvas, etched by cosmic forces over unimaginable timescales. Orion, a fleeting moment in the universe's grand, cyclical drama of birth, death, and rebirth. It embodies the relentless engine of cosmic creation. Every star, every cloud of gas, tells a story of an infinite dance, stretching back to the dawn of time, and forward into an uncertain future. What grand cosmic forces sculpt such wonders? How long do they endure? And what secrets do they hold about our own origins? To understand Orion, we must look beyond its radiant core, far back in time. Its birth wasn't a gentle blossoming, but a cataclysmic eruption. Cast your gaze wide, to Barnard's Loop. This colossal arc of glowing gas, stretching 300 light-years across the cosmic void, is a ghost. A whisper from a forgotten past. Scientists believe this vast loop is the remnant of an ancient supernova, an explosion millions of years ago. Imagine a star, hundreds of times more massive than our Sun, reaching the end of its life. Its core collapsing, then rebounding, unleashing an energy pulse so immense it outshines an entire galaxy. That catastrophic event wasn't just destruction. It was the ultimate act of cosmic creation. The shockwave, propagating outwards, compressed cold, diffuse gas into pockets of matter. It gathered atoms, molecules, dust, forcing them closer, until their own gravity took hold. These dense knots became the supernova seeds. The very genesis points, from which the Orion Nebula would eventually be born. This isn't an isolated event. It's a recurring cosmic theme, triggered star formation. One generation of massive stars ignites, burns, then explodes. These supernovae don't just clear gas, they compress distant clouds, forcing them past the threshold for gravitational collapse. A cosmic domino effect, endlessly repeating. We see evidence throughout Orion itself. Subtle age gradients within the nebula, younger stars cluster near recent shockwaves, while older stellar populations reside further afield, monuments to earlier events. The iconic Horsehead Nebula, a dark silhouette against glowing gas, is another testament. Its intricate structure is a sculpted relic, forged by intense radiation and stellar winds from a nearby star, likely a product of this same cascading cosmic violence. The universe, it seems, builds its grandest structures, with fire and fury. But Orion is not merely a consequence of past events. It is a dynamic entity, changing, even on timescales comprehensible to us. For centuries, we viewed nebulae as eternal backdrops. But cutting-edge astronomy, with Hubble, ALMA, and Gaia, reveals a different truth. Through meticulous, proper motion studies, astronomers track the minuscule shifts of thousands of stars and gas clumps. We see gas flowing, swirling, stars migrating. Imagine the nebula as a vast, ethereal ocean, with currents, waves, and eddies, constantly reshaping its shores. Its delicate wisps and luminous tendrils are not fixed, they are in perpetual, graceful motion. These observations reveal Orion to be a vast, three-dimensional, hollow bubble. A gigantic, expanding cavern, carved out by powerful stellar winds and intense radiation from its central, massive stars. The nebula's heart is slowly being hollowed out, pushed outwards. The breathtaking beauty we observe today is but a fleeting snapshot in a billion-year saga of cosmic evolution. And the saga continues. Within Orion's fiery heart lies Theta 1 Orionis C, the most massive and luminous star in the Trapezium cluster, a blazing behemoth. But this star, for all its glory, carries its own inevitable destiny. It is a future supernova candidate. In just a few million years, a blink of an eye in cosmic terms, this colossal star will exhaust its nuclear fuel. Its core will collapse, and it too will explode, just as the ancient supernova that birthed Orion once did. Visualize the spectacle. An explosion so bright, it could temporarily outshine the rest of the nebula. Its shockwave will rip through the remaining gas and dust, sweeping it away, compressing new regions, and perhaps, triggering yet another generation of star formation. Orion will be dramatically reshaped. New structures will emerge from the chaos, while older ones will be obliterated. A cycle of destruction and rebirth, eternally written in the stars. But even this dynamic ballet has an endpoint. Nebulae, for all their splendor, are inherently ephemeral. Powerful winds from newly formed stars, coupled with supernova blasts, gradually disperse the gas and dust. In perhaps 5 to 10 million years, a relatively short span in the universe's vast ledger, the Orion Nebula, as we know it today, will fade. Its luminous clouds will thin, its intricate structures unravel, until only a loose association of stars remains. The raw material will have been consumed, or scattered. This iconic celestial landmark, a beacon for millennia, will transform. It will become a memory, a collection of scattered stars, whispering of the glory it once held. Its grandeur is fleeting, a reminder of the transient nature of even the most spectacular cosmic phenomena. Perhaps the most profound revelation Orion offers is a glimpse into our own deep past. Orion is not just a beautiful spectacle. It is a mirror. A reflection of the chaotic, high-radiation environment where our own sun, and eventually, our solar system, was born. Evidence from meteorites found on Earth, ancient cosmic fossils, reveal telltale signs. They contain isotopes like aluminum-26 and iron-60, radioactive elements that decay rapidly. Their presence suggests a supernova explosion, much like the one that seeded Orion, occurred very close to our nascent solar system, injecting these isotopes into the protoplanetary disk. This isn't just theory. We observe proplids in Orion today, young stars still surrounded by their own disks of gas and dust, potential solar systems in the making. And within these nebulae, we find incredible chemical diversity, complex organic molecules forming under the harsh glare of massive stars. Our Sun, too, was likely forged amidst such stellar turbulence, blasted by powerful winds, irradiated by intense UV light, its disk peppered by cosmic debris. The birth of our own star, our home, was not a serene event. It was a violent, dynamic process, akin to the furious creation we witness within Orion today. By studying Orion, we don't just explore distant stars. We gaze into the cradle of our existence, understanding the turbulent, yet incredibly fertile conditions, that gave rise to everything we know. From that violent, dynamic process, a crucible of cosmic fire, Orion emerges not merely as a celestial spectacle, but as our most invaluable guide. It is the universe's own Rosetta Stone, laid bare for us to decipher. Within its vast, incandescent clouds, the intricate hieroglyphs of star formation unfold in real time. Orion is our nearest, most luminous classroom, a galactic observatory where the fundamental lessons of cosmic evolution are taught with breathtaking clarity. We peer into the swirling nebulae and witness the very genesis of celestial bodies. Its proximity allows us to discern the subtle nuances, the precise mechanisms that elsewhere remain obscured by light years of distance and the veil of cosmic dust. Every luminous filament, every nascent protostar, every collapsing gas cloud within Orion, provides critical data that challenges old paradigms and refines our most advanced astrophysical models. From the first, tumultuous flicker of stellar ignition, to the elegant choreography of gas and dust coalescing into protoplanetary disks, the nurseries of future worlds, Orion reveals the complex interplay of chaos and order. Here, violent stellar winds sculpt vast nebulae, yet within those turbulent currents, the delicate seeds of new planetary systems take root, a testament to the universe's profound capacity for self-organization. The legacy of Orion extends far beyond its present splendor. It is a prolific cosmic parent, having birthed thousands upon thousands of stars. Each one, a wanderer now charting its own course across the galactic tapestry, carries the indelible chemical fingerprints of its turbulent birthplace. These stellar progeny, imbued with the elemental heritage of Orion, will eventually see distant regions of the Milky Way, their unique compositions telling a story of creation that echoes through epochs, shaping future generations of stars and planets. This magnificent nebula doesn't just shape stars, it profoundly shapes human understanding. Orion is a crucible for our most sophisticated instruments, pushing the boundaries of observational technology and deepening our cosmological theories. It ignites our collective imagination, inspiring artists, scientists, and dreamers to ponder our place in this vast, unfolding drama. Orion serves as a fundamental benchmark, a cosmic standard by which we measure the universe itself, a vibrant, pulsating heart of creation. And as long as we turn our gaze skyward, Orion will continue to whisper its timeless secrets, reminding us of the violent beauty, the intricate order, and the enduring wonder at the very genesis of everything we know.